All right, guys. So yesterday we started with the lesson, and our objective is I can simplify exponential expressions with fractional exponents, right? Okay, let's read together. 1, 2, 3. I can simplify exponential expressions with fractional exponents. So pretty much yesterday I gave you guys the properties, and all you have to do is apply them to some of the problems that we had over the homework. However, some problems seemed a little bit too complicated because it just had a couple more steps than what you're used to, right? So we're going to do some practice ones right now, and hopefully that'll help you get through some of the doubts that you have on some of the problems that you didn't get, right? So here we go. So just to clarify, we know what exponential expressions are, right? We don't have to write our Ferrier model. We know that they are numerical and variable expressions raised to a power greater than 1. I asked you guys to copy the steps. Remember that? Terminology that I covered were radicals, and we said that's what we used to call square roots. Factors are 2 or more numbers that multiply. And also index is the little number outside of the radicals. Remember that? Okay. So then yesterday I said we're going to continue focusing on a common core standard called Math Practice Standard number 6, which is a 10 to precision. A 10 to precision. Agree with me? All right. So I covered some terminology such as prime numbers and composite numbers. And I said we're going to focus on prime numbers, the first 5. Remember that? And I said the first 5 prime are what? 2, 3, 5, 7, 11. Remember those? And those are the first 5 numbers that you're always going to check to see how you can start your prime factorization of the numbers that we have in the radical. We did prime factorization. I showed you guys how to do the factor tree. Remember that? And then also I said from now on, let me show you how to rewrite some exponential expressions that have fractional exponents, such as x to the 1/4 becomes 4th root of x. Remember that? Same thing if I have, let's see, if I have 16 to the 1/4, this becomes what? 4th root of 16. Remember that? All right, so we got through that. And then from there, I said, let's do some practice problems. We did these. Remember those? Then we did these. Remember those? Okay. And then we left off, I was explaining that in order to simplify a fraction such as this, 2/3, it can be rewritten as 1/3 times 2. Remember that? Okay. So what if I said, let me give you another fraction, 4/5. This could be rewritten as 1/5 times 4. Is everybody getting there? And why is this? Because what did I say at the beginning of the year? Whenever we multiply a fraction in the whole number, we write it over 1. So it's 4 times 1 is 4. 1 times 5 is 5. This one is 2 times 1 is 2. 1 times 3 is 3. Are we there so far? From there, this is where we left off. I'm going to give you this one. This is 27 to the 2/3. The first thing I said, we need to rewrite the fraction like this. So this becomes 27 to the 1/3 times what? 2. Does everybody see that? Okay, so this became that. But still some of you did not see it. I saw some of you kind of like iffy. However, if we break it down to parts and I circle this piece, does this look familiar? Yeah, remember I showed you guys that if we have this, we can rewrite it as a radical to the index of that exponent. Does everybody see that? So therefore, what does this become? Think about it. This becomes what? Cube root of 27. Now check this out. What operation is this? Multiplication, so that's why you need to open up parentheses there and then bring down the 2 right there. Copy this, please. All right, so far so good, right? All right, so let me do the next step. So if I was to continue from here, Pens down, eyes up here. Because I sensed, like, I thought you guys understood it, but I still sense some of you are still a little bit confused. So I'm going to focus just on the red. If I focus on the red, the next step here is to find the prime factors. Is that correct? Therefore, I start my factor tree. And what are my first 5 primes? 2, 3, 5, 7, and 11. So which of these divides in here? 3. This becomes 3 times 9. How about this one? 3 times 3. These are all prime. Is that correct? So this becomes cube root, and now instead of writing 27, what am I, guys, focus, instead of writing 27, what am I going to write? 3 times 3 times 3. 3 times 3 times 3. Where did I get those from? Here. Are we there so far? I bring down my parentheses, and I bring down my exponents. All right, so then what is this saying? It's saying what number multiplies itself 3 times in here, now that we have it prime factored? What number is that? 3. So we rewrite it right here, and that's going to be 3 parentheses to the second power. So what is 3 to the second power? This becomes 3 times 3, which is 9. Copy that, please. So, any questions with that? Copy this one down. Example, mega cube. Here we go. 8 to the 2/3 power. Let's do this one together. See how we do. So look at it. Think about how would you rewrite that? Okay, rewrite it and see if we agree. Okay, who rewrote it as 8 to the 1/3 times 2? Is that correct? Okay. From there, we have to circle this so that we know and we keep step by step doing what we need to do. And what does this become? Doesn't this become a radical? Yes, this becomes cube root of 8. Are we there so far? But what does this indicate? Multiplication, so that's why we open up parentheses and we bring down the 2. So far so good? What did we do to the 8? Factor tree. Remember? Once again, we start with 2, 3, 5, 7, and 11. Which one? 2 times 4, and this is 2 times 2. So let's rewrite this. Cube root, and instead of 8, we get 2 times 2 times 2. Bring down the parentheses and the square. So what number is multiplying itself 3 times? The 2. Bring down the second power. So that becomes 2 times 2, which is 4. How are we doing with this? Yes? Okay. Try another one. Here we go. Example. I'm sorry? Oh. Let's do example Shazam cube. Here we go. Let's do 16 to the 3/4. See if you can do that by yourself. Steps. Okay, so for this one, first things first, we need to rewrite it. This becomes 16 to the 1/4 times 3. Answer be that. Okay, good. From there, you circled what you already know, which is this. We know how to do that. That becomes 4th root of 16. And the multiplication indicates that we open up parentheses and the power goes outside. So far, so good. This becomes 2 times 8, 2 times 4, 2 times 2. So this becomes 4th root of 2 times 2 times 2 times 2 to the 3rd power. Sorry. Okay. So therefore, what number repeats itself 4 times? The 2. So this is 2 to the 3rd power. So this becomes 2 times 2 times 2, which is 8. Okay? Let's try another one. Copy this one down. See if you can do those two by yourself. We got simplify each expression. A is 81 to the 5/4, and B is 3,125 to the 2/5. Go. All right. A, the first things first, we need to rewrite this. This becomes 81 to the 1/4 times 5. And speed is that. Okay. From there, you know you have to rewrite this, so you circle it. This becomes the 4th root of 81. Does it have a multiplication over here? Yes, that's where you open up parentheses and we bring down the 5 or the 5th power outside. We bring down the 5th power. From there, factor tree. This becomes 3 times 27, 3 times 9, 3 times 3. We rewrite this. This is 4th root of 3 times 3 times 3 times 3. And all that to the 5th power. So what number is multiplying itself 4 times? 3 to the 5th. This becomes 3 times 3 times 3 times 3 times 3. So let's check this out. So, from there, what is 3 times 3? 9. What is 3 times 3? 9. What is 9 times 9? 81. You bring down the times 3, this one, the last one. So, 81 times 3 is 243. You guys see where you made a mistake? Those of you that made a mistake? No? Okay. Yes, sir? Okay. Let's go over this one. Here we go. Let's rewrite it first. This becomes 3,125 to the 1/5 power times 2. Are we there? So that becomes, let me see, this becomes 5th root of 3,125 and all that to the 2nd power. So once again, we got 2, 3, 5, 7, and 11. Which one of those divides into here? If it ends with 0 or 5, it has to be what? 5. So 5 fits into 31 how many times? 6 into 12 twice, into 25 5. Okay, and again, this is 5, so therefore it fits into, oh, it fits into 6 once. We have 1 left over. Into 12 it's twice, and then into 25 it's 5. From there, 5 fits into that how many times? 25, and the 25 becomes 5 times 5. So we rewrite this. This becomes fifth root of 5 times 5 times 5 times 5 times 5, and all that to the what power? Second, yes? Some of you that already see it from here, if you want, you can go bypass the step. But once it gets to other numbers, I want you to write them out because then you're going to see it a little bit better. So here we go. So what number is being multiplied 5 times? 5. And what is 5 squared? 5 times 5, which is 25. How are we doing? Yes? Okay. So now that we have plenty of those practice, let me go to these. Give me a second. There were some word problems that all you had to do is substitute a value, and you're going to end up with something that we just had right there. But I want to address this one. Copy this one, please. Just write simplify. Write the word simplify, and then you copy this example. From there, you just go like this, and we're going to rewrite it. Is that correct? Because we need to break these down, don't we? So check this out. This becomes 4th root, so write what I write. So this one becomes A times A times A times A. Is that correct? This one becomes B times 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 B. Okay? So, the question is, if we look up, the index is telling us which numbers multiply in itself how many times? 4. So which one is it? A, so we bring the A out. There it is, and A to the first power, right? Okay. What other? Let's see. A B. There's 4 of them, so I write B. How about another 4 here? Yep, another B. How about another 4 here? Yep, another B. How about another 4 here? Yep, another B. And how about another B for that one, right? Thank you. Okay, so with that said, we end up with this. So what do we know about these? They're all 1. Are they the same base? These? Yes. The B's, yes. So this becomes B to the what? 5th, and this is A to the 1. Are we there? And that's what we have. Now check this out. Pens down, eyes up here. See if you see what I see. Something happens, this and this, to give me this. Something happens to this one and this one to give me that one. In order to avoid doing all that, tell you never what happens. So pretty much to simplify, we said what? We divide the exponent by the index. Are we there? Pretty simple? All right, so check this out. Copy this last one down. You're saying, oh, Mr. Q, that looks really hard. Well, it's not. Just copy the word simplify and copy this one. Here we go. So we already know how to do this. If we look up, if I was to cover this radical, do we know how to do these kinds? Yeah, what happens to the exponents? They multiply, so let me do that. What is 1/2, oh, sorry. What is 1/2 times 6? That's 6 times 1/2. That becomes what? 6 over 2, which becomes 3. So this is x to the 3rd. Are we there? Okay, we're multiplying first the exponents, right? So 1/2 times 6. You know this is over 1. So 6 times 1 is 6. Da, da, da. This simplifies, so that we're done with that. Next, 1/2 times 4 for the y. 4 times 1/2. This becomes what? 4 over 2, which is 2. So we're done with this. But now let me move this piece out. I bring that one down. There you go. Square root of y squared. What did we just find out about this exponent and the index? What is the index out here? Does it have one? But it's a what? 2. So what do we know about these two? They divide. 2 divided by 2 is? So we end up with y to the first. And I bring these down. X cubed, y squared. And what happens to these that have the same base? Y to the third. And I bring this one down. And I'm done. Pretty simple? You just need to do one piece at a time. Okay? That's why last night you probably missed some of these because you didn't see each piece separate. It was just a little bit maybe too much in front of you. So for homework, make sure you view this lesson, Fractional Exponents, Part 1 and Part 2. That's why you're going to take some Cornell notes from the back, right? And also you're going to pick one also from the multiplication and division of properties. Also, you're going to take notes on that. And you're going to correct your parties that you made mistakes on, right? And get those signed brought back to me on Monday. Have a good one, guys. Enjoy your homework. Turn in your homework on your way out in the inbox. See you guys on Monday. No.